Hello there, Cougar Academy, Algebra IIB, and welcome to Lesson 6.8. This is the last lesson in Unit 6, so welcome. We have one more theorem to introduce to you today, and that is the conjugate root theorem, okay? The conjugate root theorem basically states that if you have a radical or imaginary root, so if you have a radical and irrational or imaginary root, you always have its opposite. Okay, so for example, if I know that I have the square root of 7 as a solution, you also have the square root of -7. If you know that you have 3i as a solution, you automatically have -3i as a solution. So we call those conjugates. One is positive, one is negative, and that is what this theorem states, is they always come in pairs, okay? They say good things come in pairs, I suppose. So just like peanut butter and jelly and all that, if you have a positive square root, you have its negative as well. So what we're going to be doing is we're going to be creating polynomial functions with given roots and using the conjugate root theorem to just fill in some gaps here, okay? So our goal is to write a polynomial function of least degree with integral coefficients that has the given zeros. So here's how the problems will look. Sometimes I'll be giving you radical roots, and you are given the following zeros. So that's what these commas represent. These are the zeros, okay? In the past, we knew that we could automatically write this as the 0x minus the root of 7. And this next one would be x minus 5. So we did this last lesson, okay? And we're making a function, so we're going to say this is f of x. Okay, now the bonus thing is, using our conjugate root theorem, we know that we also have x plus the root of 7. That is the new bit, and we know that we automatically have negative square root of 7 because that's the conjugate, okay? Now the reason that this is actually x plus the root of 7 is because it's kind of like x minus a negative, okay, which becomes positive. Now that we have those zeros written down, we do want to make a proper function of this. So let me rearrange this a little bit. It's helpful if you put the conjugates next to one another. We're going to use some FOIL techniques here. So I want the conjugates next to one another, and I'm going to encourage you to use FOIL on those. First, outers, inners, last. You should notice some magic happen. When we do the firsts, you're going to get x squared. The outers is going to be positive roots of 7x. The inners will be negative roots of 7 times x. And the lasts are going to be minus root of 49. So the magic that happens is, well, the square roots of 7x are going to cancel, and that's going to leave us with just x squared. The square root of 49 is just 7, so minus 7. So all that just came out to be x squared minus 7. Pretty fancy. Now we still have the x minus 5. That's going to come down in the end. But then we just have to do FOIL one more time to get our actual function. So by doing FOIL one more time, we have our function is going to be x to the third, outers minus 5x squared, inners minus 7x, and plus 35. Okay, if you were to solve that equation, Using our methods from before, you'd get those 3 zeros, okay? So basically, you write down the freebie, the conjugate, 0, and then you get to use some FOIL and such, okay? Checking out another example here, number 2, using our conjugate theorem, we know already that we automatically have negative 2 roots of 2. That is our freebie. That's the conjugate that we have because we have the positive version. Okay, so let's write these out as our factors. Let's call this function g of x. Why not? So we have x minus 2 roots of 2, x plus 2 roots of 2, and also x minus 4. I know I wrote them out a little different here. Here's the 0 for that. Here is the 0 for 2 roots of 2, and the 0 for that there. Okay, with these next to each other, it makes FOIL easier. So, FOIL that, x squared minus 2 roots of 2x plus 2 roots of 2x minus, the tricky part is it's going to be 4 roots of 4. Where did that come from? When we take 2 times 2, that gives you 4. And the square root of 2 times the square root of 2 makes it the square root of 4. Now again, we just have been foiling. Magic will happen. The roots of 2 will cancel. What we have is x squared minus 4. The square root of 4 is 2, which means we have x squared minus 6. X squared minus 6. Okay, so where did that all come from? Just some fancy math here. Now, don't forget about the x minus 4 at the very end. That's this factor. And a final bunch of FOIL can get us our final function. G of x is equal to x to the third minus 4x squared minus 6x plus 24. Okay, so that's it. Hopefully you're noticing it's not too bad compared to some of the other stuff we did, essentially giving you a free 0 and going from there. Okay, the last 2 examples just deal with imaginary roots, and it's really the same idea. So this time, if you're given an imaginary root, like 3i, I automatically know I have negative 3i that comes along. We'll name this function h, and making our zeros, we would have x minus 3i, we add x plus 3i, and we also have x plus 2. Be careful, again, factors are always opposite signs. Maybe write that for yourself. Here's the x minus 3i factor, and use another color. Here's the other one there. Okay, same process. You just need to notice something else when you FOIL here. So we're going to use the FOIL process. X times x is x squared. Plus x 3i. It doesn't really matter how you write those. They're just going to cancel. The tricky part is this last part. Minus 9i squared. Maybe remember that I squared is really negative 1. Okay, so what we have going on here, the x 3i's cancel. We're going to have x squared minus 9 times negative 1, or x squared plus 9. So that's a little tricky part there. At the very end, just another bunch of FOIL to get us going. X to the third plus, that was our first, outers, 2x squared plus 9x plus 18. Bada bing, bada boom. That is it there. So really the only curveball with that is making sure you get that negative 1 from the I squared. Okay. For number 4 here, So I give you negative 7i. We know that we automatically have positive 7i. That's our freebie. And we'll make this one b of x. Why not? And write out those zeros. Okay. You can FOIL the last two. I'm going to skip the outers and inners. I know they're just going to cancel. So I'll just do the minus 49i squared. If you catch that little trick, you could do that too. That's going to be x squared plus 49. And then we're going to have the x minus 2. FOIL one last time. X to the third. 49x. I'll do the proper steps. First, outers. 49x, I suppose. Minus 2x squared. Minus 90. No, 49 times 2. Come on, Mr. Dvorsky. 49 times 2. I can't think right now. Calculators there, 98. And properly written, 2x squared plus 49x minus 98. If you don't write it that way, that's okay. But you should have those same coefficients and so forth. Okay? So good job with that. I hope this lesson wasn't too taxing. Conjugate root theorem, writing imaginary roots. And please practice those problems, and good luck.